Hello and welcome once again to physics tutorial brought to you by O3 Schools JAMB app. Remember, O3 Schools JAMB app is the application you download and install in your phone so that you can get access to features which can help you as you prepare the JAMB examination. You can get It gives you mock exam properties. You can actually prepare and give yourself a mock exam to see how you may score in your actual exam. There are other things there, such as find my institution's picture, which helps you find institutions which offer the course of your choice, even to help you find out the subject combination for a particular course. You can see this and more in the application. How do you use your application? Download, install, and activate. Yes, activation is very important. And the activation fee is simply 2,500 naira. Simply click to activate on your app and follow the steps, and your app will be activated. There's no reason to be afraid that your application will not work or things like that. No, no, no. With O3 Schools, you are guaranteed. Once you pay, your activation comes, and you can start using your app and gaining access to all these features and more as you prepare for your JAMB to make your learning easier and faster. And with that, let's come to today's physics class, and we shall be looking at friction. Friction, yes. What is friction? Friction is that agent, or rather, friction deals with force first of all. Let's not talk about friction, let's talk about force. What is force? Force is that agent which changes or tends to change the position of a body. If an object is stationary, say a box is here, before this box will change, force has to be applied. Now, the definition carries which changes or tends to change for the simple reason being that the application of a force is not a guarantee that this object will change position. You could go push your wall, for example. Push your wall and apply all the force humanly possible. You're not going to make your wall move. You're not going to put your house from your street to the next street. No. So you are tending to change while not quite succeeding. But with a table, you can apply force and actually change. Therefore, force is agent which changes or tends to change the equilibrium position of a body. Now, also, you should know that there are different types of force, basically divided into two: contact force and field force. Contact force is one where they have to make contact, you have to physically touch the object for the object to experience that force. While for a field force, there doesn't have to be any physical contact. You can experience the force while the object creating the force or producing the force is still at a certain distance from you. The example of contact force is your push and pull, and also frictional force, which is what we are going to focus on. One example of field force is like a magnetic force, the electric force. Two magnets can interact with each other despite not touching. Alright, so now once we've taken force out, what then is friction? Now, friction itself is the opposition to motion on a body between which has two surfaces in contact. One more time, it's the opposition to motion provided by two surfaces in contact with each other. Say, for example, I have a box and I'm trying to push it again on the ground. Now, if you ever try pushing the box, the moment you apply force, the box doesn't just start moving. No, there's an initial sort of resistance you feel before you actually overcome that resistance and the box begins to move. That resistance is brought about because the surface of this box is making contact with the surface of the ground. And as soon as that happens, a force known as friction gets introduced into the equation. Now, friction is always acting opposite to the force. So if you try to push it this way, friction acts this way. If you come this way and try to push it this way, friction acts this way. So friction always tries to oppose. And after types of friction, there is static friction, and then there is dynamic friction, or limiting friction, or some even call it kinetic friction. What's the difference? Static friction is the friction you feel before you start to move. Before this box starts to move, you must first of all overcome static friction. However, once the box has started moving, then has to overcome dynamic friction. That's the difference. So static before it moves, dynamic after it has started moving. Now this frictional force has about 5 laws which govern it. There are 5 laws that govern solid friction. And then what are these laws, you may say? Okay, now for the laws of solid friction, in no particular order, the first law says that friction is independent of the area in contact with each other, independent of the surface area of the two bodies in contact with each other. It doesn't matter how wide area is or how small. Friction doesn't care about area, no. But friction is dependent on the nature of the surfaces. Friction rather cares about the nature of the surface. A very, very rough surface will have a much higher friction than a very, very smooth surface. So that's the second one. 3, friction always acts opposite the intended direction of motion. Opposite motion, basically. So if motion tends to move to the left, friction tends to move to the right. If motion tends to happen at an angle, friction will also tend to happen at an angle perfectly opposite the initial angle. So friction is always opposite motion. And the fourth one is that friction is independent of the sliding velocity. So it doesn't matter the velocity with which these objects are moving across each other. No, friction doesn't depend on that. While the last one, and that's why in a way almost the most important one, states that friction is proportional to the normal reaction. Simply saying that friction proportional to normal reaction. And what is this normal reaction? If my surface is perfectly smooth and horizontal, sorry, not perfectly smooth though, but horizontal, and my force is here or my body is here, then my weight is going downwards and the normal reaction must be going upwards. And since action and reaction are equal and opposite, then my reaction is basically also equals to my weight mg. So friction is proportional to normal reaction. Choosing your constant to remove the variation sign, constant is mu, and this mu will be equals to F over R, and that is the coefficient of friction. That's what mu represents, coefficient of friction. And typically, please note, like we have here, the normal reaction is usually equals to your weight. So in some situations, if you recall that F equals to ME, you may have ME over normal reaction, which is mg, and they cancel out, mu equals to A over G. And then last but not least, if you are on an inclined plane, you want to find the frictional force there. There's a lot of proving that goes into it, but the simple thing you should come out with, the one single thing you must remember, is that for inclined surfaces, then mu equals to tan theta. So those are the formulas you should note. This, remember my reaction is mg, this, and this. Now, an occasional question that can occur in your JAMB in times is, when the surface is perfectly smooth, what happens to friction? Now, as you are aware, the smoother the surface, the lower the friction. And if it's perfectly smooth, therefore, your frictional force should be 0. Therefore, if you look at this here, if my frictional force here is now 0, if my mu must also be what? 0. So for smooth surface, for perfectly smooth surface, therefore mu will be 0. While for perfectly rough surface, is perfectly rough, the mu is basically infinity, raising the frictional force also to infinity. However, is friction useful? Yes. Friction aids walking. Without friction, you should be sliding along the road and you won't do anything. Friction also aids the brakes of your car. Without friction, if you apply brakes, basically you'll be wasting your time. Nothing will be happening. But does friction also have disadvantages? Yes. Friction leads to wear and tear of machine parts. As you're aware, any two parts moving over each other, eventually they need to get worn out and then they can tear. Friction also leads to heat. And you can test that by rubbing your hands together. They begin to get hotter. So friction leads to heat, which can make some of your devices overheat just because of friction. Then friction wastes energy. Your aim with all these devices initially is to move. Friction tries to oppose, and therefore you have to oppose friction first. So energy that I've used to perform useful work to you gets wasted overcoming friction. So since we know friction has advantages and disadvantages, what about ways of reducing friction? There are different ways actually. There's lubricating, which is simply using grease, commonly engine oil, to cover these things to make it smoother. Then there's use of ball bearing, and last but not least, there's streamlining, which simply means making the shape such that it is easy to cut through the air. Streamlining most times occurs when you're talking about friction with air. Your airplane, for example, needs to cut through the air easily when flying, not battle with the air. Therefore, the shape is streamlined to make this easier. So, this is friction, and with this, actually, we can open our O3 Schools JAMB app and then begin to solve questions, simple questions. So, getting our O3 Schools JAMB app on our device, let's work together and see some questions and also their answers. Okay, our first question is purely theoretical, and I think I just answered it. Questions from 2016, question 49. It states the coefficient of friction between two perfectly smooth surfaces is what? And the answer is 0, like we just stated. For perfectly smooth surface, in that situation, your frictional force is 0. Therefore, mu must be 0. So that's our answer, option C. Then next we have also on that question we just answered. Which of the following, again, sorry, the question is from 2016, number 31. Which of the following could be used to reduce friction? A, water, B, kerosene, C, grease, and D, petrol. Like we stated previously, its answer is grease. Okay. Next, we have from 2015, number 24. Okay. This one is from the year 2015, and this is number 24. A 100 kg box, mass of the box is 100 kg, is pushed along a road with a force of 500 Newton. If the box moves with a uniform velocity, the coefficient of friction between the box and the road is what? And G is 10. I want to find mu. Now, obviously, if the box is going to move with uniform velocity, it means there's no extra force acting on it, implying that this force of 500 is equal to the frictional force. And remember, F equals to mu r, and mu equals F over r. Now, F is 500 Newton, and r, as we remember, normal reaction is equals to mg. So m is 100 times g, which is 10. These two zeros take care of those two zeros, and 5 over 10 is simply going to be 0.5. Option D. So you see, the solvings are that simple. Question 2. In this case, we are told an object of mass 20 kg, we have mass again, and it slides down an inclined plane at angle of 30 degrees. Let's find the coefficient of static friction. Now, if you remember, I stated clearly that if you're having an angle theta, there's no real reason to even bother with long solving. Your coefficient of friction mu equals to tan theta. So that would be tan 30 And in case you don't know the value for tan 30 in decimal, you should at least know in short form that tan 30 is the square root of 3 over 3. So if you simply open your calculator, which yes, JAMB calculator can do, press square root of 3 and divide that by 3, you get 0.577. And approximately, since all your answers are to one decimal place, must give you 0.6. And so you see, the answer is option D. No need for long solving. Then the next question comes to us from 2012, question 12. And for this one, there's no reason to solve. Because again, we have an inclined plane, and we are told that if the angle is alpha now, rather than theta as before, we have to find the coefficient of frictional force between the block and the plane. And we'll just emphasize that the formula must be tan theta. But since they're calling the angle alpha now, then the answer will be tan alpha, option B. See, these are truly simple. Okay, that question, by the way, was from the year 2012, question 12. Let's move on. Now we are going all the way to the year 1999 and taking a look at question number 7. This one says, when the brakes in the car are applied, the frictional force on the tires is what? When you apply brakes to your car, does friction help you or not? Obviously, yes. Friction helps you because without friction, your car would not stop. So the friction on your tires is an advantage. However, both C and D have advantage. C says it is an advantage because in the direction of the motion of the car, while D says it is an advantage because in the opposite direction of the motion of the car. Like we stated, friction always opposes motion. Therefore, the frictional force can never be in the same direction as the motion of the car, making my answer D. It's an advantage, yes, and it is opposite the direction of motion of the car. Okay, all right, next we have 2003, question 6. In this one, if an object just begins to slide on a surface inclined at 30 degrees to the horizontal, again we have 30 degrees, to find the coefficient of friction, just like previously, mu equals to tan theta, which is tan 30, and we know this should give me root 3 over 3. However, if you look at the options, I don't have root 3 over 3 there. And then I would like to remember that root 3 over 3 is the rationalized form of the answer. That the actual answer for tan 30 in mathematics is 1 over root 3. In case you've forgotten, just know the reason why we take root 3 over 3 as the answer is because this will give us times root 3 over root 3. Root 3 times 1 is root 3. Root 3 times root 3 is 3. Therefore, my answer will be 1 over root 3. In case you can't do this, you can still remember, if you press root 3 over 3 on your calculator, you get 0.5774. You could simply try pressing each and every one of your options into your calculator to see which one will give you that same number. And that will still give you 1 over root 3. Okay, let's move on. Our new question comes from the year 2008. 2008, question 13. A motorcycle of mass 100 kg, motorcycle has a mass of 100 kg, moves around in a circle of radius 10 meters with a velocity of 5 meters per second. We have to find the coefficient of friction between the road and the tires. Now, this might seem a little bit difficult, but just remember, if any object is moving around in a circle, then we should be looking at centripetal force. And centripetal force F equals to mv squared over r. So that will be 100 times v squared. V is 5 squared over r, which is 10. So 0 cancels 0 here. This will be 10 times 25. And that will give me 250 Newton. So that is the force. And then if you remember that mu equals F over R. F is 250 and R is mg, which will be 100 times G, and G is 10. And if you simply press this into your calculator, that will give you 0.25. See, and that is our answer. Very simple. And that leads us to one last simple question, and we can call it quits with friction. This one says, find the magnitude of the force required to move a 20 kg object along a horizontal surface if the coefficient of friction is 0.2. And as usual, G is 10. Want to find the force to move it. Now, if you remember, again, F equals to mu R. And in this case, R, as usual, normal reaction will be mg. So mu is 0.2, m is 20, and g is 10. 20 times 10 is 200. 200 times 0.2 is 40 Newton. And therefore, the force required to move it is 40 Newton. Option B. Alright, and with these, I hope we've learned about friction, its analysis, and solving. And now to thank you very much for watching this video, again presented to you by O3 Schools JAMB app. Remember, subscribe so that we can also watch more videos and more tutorials on different topics, and not just in physics, but from other subjects as well. My name is Athanasius. Thank you very much for watching, and do not forget to get your O3 Schools JAMB app and activate it. Thank you again.